Hi, I'm Leo. So I'm a product engineer at Incident.io, where we build a product that handles your end-to-end incident management. So from your alert firing to it paging you all the way through to your postmortem. And I've spent most of the past 3 years building the on-call part of that. So making sure that those alerts reach the right person, whatever happens. But I want to start by talking about the on-call that everyone is more familiar with. So most of us in this room are building products that people depend on, for example, payments or deployments infrastructure, and products that are used daily by engineers and non-engineers. And when you're on call for one of those systems, the stakes are high. And however well you balance reliability against shipping new features, things break and incidents happen. And incidents are stressful. When I first started being on the pager and I got paged and things seemed to be badly broken, my heart would race. And I want to talk to you about how an incident, we get the upside of incidents without the stress or the customer impact. And I want to start talking about why this matters to me. And for that, I need to take you back to a particular incident. So let's go back a couple of years, back to 2024. So in the latter half of the year, we'd been getting recurring alerts for high CPU, and these would usually self-resolve, but we tracked them down to be due to a specific API endpoint. It's an API endpoint we use to calculate who's on call for a schedule. So it's an endpoint we use when you're editing a schedule, but it also powers a little widget that shows you who's on call that's always there in the corner of the dashboard. So it has to stay efficient because we use it quite a lot. And we'd identified a few issues with it, and we'd made some improvements and resolved those alerts. And now you have this context. If we go to December 2024, I was on call and halfway through a week-long shift. It had already been pretty noisy for other reasons, and I had actually asked for cover from 10 p.m. on, and you can guess where this is going. So it was 9 p.m. and I got paged for a WebPod CPU being higher than normal. So I acknowledge and I pull metrics on the pod, and I tell myself, okay, it doesn't actually look too bad. The CPU looks a bit spiky, but nothing saturated, and I can load the dashboard, so we're all good. But then more things start happening. So 3 alerts come in, more of the same. WebPod CPU is high, and our HTTP API probe failing intermittently. And I managed to find a familiar culprit that's driving this high CPU. So this is the duration we're spending on that on-call endpoint. And there's some engineers hanging around Slack who are offering some help. And it's at this point that Steven, our CEO, pops up in the incident and lets us know of a customer report that might be related. And at this point, it's not looking like things are fine. It's looking like things are maybe a bit more broken than I thought, and a customer is actually impacted. And I had all the signals I needed here. I had engineers offering to help. Each alert had a runbook attached. But instead of trying some mitigation strategies, I just felt like this dog that you might be familiar with. I was able to hand over this to an incident who successfully mitigated the issue, but it took 10 minutes longer than it should have, and as I stepped away from my laptop, it felt like I'd cost us some reliability, even though I'd known what to do. So after that incident, I remember taking a conscious decision that I wanted to get more comfortable with incidents instead of getting so stressed by them that I couldn't respond. But that happened, but it took more incidents and stress and cost. The reality is that incidents make you stronger. They make you more confident as a responder because you get better instinct, you get more know-how. And for your product, it's reinforced with fixes and more follow-ups. And when I talk about incidents here, I mean more severe incidents, the kind that require a higher level of communication with your customers and maybe coordinating a whole lot of responders. And this is a problem because incidents are stressful and have a cost to your customers, so they're valuable, but at a very high price. So incidents improve your reliability, but what you want is all of that without the cost to customers and really to yourself. So how do you skip the incident? I want to talk about how you can leverage game days, which are pre-prepared, simulated major incidents, and to build on your reliability. So I'm going to show you how you can run the process end-to-end so you get a successful game day. So first, setting the stage. So what do you want this game day to achieve, and who is going to carry this process end-to-end? How do you then come up with scenarios that deliver on that goal? And how do you make it feel real without breaking anything in production and overwhelming your responders? And at the end, how do you walk out better and wanting to do it again? And at the end of this talk, it should feel like you can run a successful game day that doesn't feel like a performative exercise, and that gets you the whole value of a real outage, as well as training your responders. Cool, so let's set the stage. So to get started, you want to determine your goal. So why are you going to be running a game day? We found that incident response is a combination of systems, processes, and people, and you want to take that into account when you're determining your goal. So let's go through some examples of goals you might have. So first, you might want to test response to unlikely scenarios. So plausible scenarios, but that once they happen and are the real deal, it's a bit too late, and you'd rather just be prepared for them. So for example, here we have a game day incident where we leaked a Slack webhook signing secret, and that's Pete, our CTO, pretending that his son was the cause of it. And this is a great way to test your people and processes for scenarios where you might not have any other chances to do it other than the real deal. Another goal would be to test response to common failure modes. So this is a type of game day incident that we run quite often, where we want to focus on processes and systems more than people. So we commonly include instances where we trigger high CPU on our pods or high memory, and then we focus on how our people are able to use actual processes, known processes, to mitigate those. It's also, when you're running those, a good test to see what is actually feasible to do to trigger those, how easy it is to actually create those alerts in your system. You might also want to do the reverse of getting ahead of an outage and feel 100% confident about your fixes off the back of an outage. So how would you respond to a similar outage to one you've just gone through? And I want to dig into this one a little bit more because that's the last game day that we ran off the back of AWS going down, which some people have already talked about today, but here we go again. So in October 2025, US East 1 went down. And we don't actually run on AWS, but we were impacted because some third-party vendors that we use for some of our features, do. And we had a whole bunch of follow-ups that were promptly prioritized and fixed, but we wanted to make sure that we would not face this situation again, or it to happen again. And we could have covered this with drills and runbook walkthroughs, but game days gave us the opportunity to check what would happen if the failures compounded together again. So we decided to run a game day. Once you know why you want to run a game day, you need some champions to carry it through end to end. And so these champions will be both your facilitators and your villain squad. So planning the whole thing, but also making sure that everyone is having a good time while they're going through simulated instance. So we found that an engineer and a platform engineer with buy-in and help from an EM has helped us get game days running smoothly. If you do need motivation to get engineers doing this, we found that the appeal of being in the shadows and getting to break things that they normally wouldn't is a pretty sweet selling point. Cool, so you know why you want to run a game day and you know who's going to run it. So how do you come up with actual issues for your responders? So this is the hardest part of the process. It's going to be very specific to your product and the goal that you've set. But there are some prompts that can help you come up with how you'd break things. So for example, if you look at your architecture diagram and you think about what parts of it are particularly sensitive, or is there a specific box that you really would want to be allowed to play with that you normally wouldn't? Or when you go on call, what's the one part of your system that keeps you up at night? Or finally, are there some specific failure modes or a bad incident that you've lived through that you would want to make sure that you would deal with well again? And once you've got an idea of issues that you could play with, you need to figure out how are you going to break it. Can you actually break it? So for example, it would be very easy to just return a whole bunch of errors in an API endpoint, but that's not very plausible. So is it actually feasible to break it? Do you also have an environment to break things on? So if you can't run this in production and have impact on your customers, so you need to have a plausible environment to break things on. Based on what you're planning, you also need to determine how will my breakages manifest? Do we actually have alerts that will alert me to what I'm breaking? And based on this, how will my responders mitigate what I've just created? Cool, so if we go back to our AWS outage, how did we actually come up with the scenarios here? So we came up with 3 headline scenarios. The first one being those third-party vendors being down. We wanted to make sure that the redundancy we added would help us when we break those things. The second scenario was that dashboard usage would spike. So as an incident management company, when there's a major cloud outage, people tend to flock to our dashboard. So we wanted to be prepared for that and mimic that. And the third scenario is the inability to deploy. So the reason we wanted to test this was that during the AWS outage, we found a hidden dependency in our CI pipeline on AWS. We'd fixed that, but we wanted to make sure that we would be able to respond well when we are not able to deploy, because it's a cornerstone part of our reliability strategy. Cool, so going through these one by one, how did we actually break them? So a third-party vendor we use for a feature is down. So what did we do? We triggered that by just blocking traffic with a DNS rule, which would trigger timeout when we tried to use the feature. For increased web dashboard usage, we did a bit of a bad actor thing and triggered a malicious endpoint that increased CPUs by calculating pi. And we were hoping that our responders would have a bit of trouble finding that one. Finally, for not being able to deploy because building images is broken. So this is actually one where we drew the line, and we decided we couldn't break it feasibly without impacting our actual production pipeline and the ability for our engineers to both ship features and do actual incident response. So instead, we decided we would declare it manually and see how our responders would react with the belief that they're not able to deploy. Cool, so once you've got all your issues, you want to put it all together into one to-do list so you can step through it calmly on the day. So you want to cover what you're going to break and how you're going to break it. So what code changes do you need, or what configuration changes do you need on a day. You want to be able to prove what will happen when you do break it, and if anything doesn't happen as expected, prepare some nudges for your responders. You also want to write down the expected impact and your expected response actions for your responders, and how long it should roughly take them to respond. And finally, you want to add some cleanup steps so that you don't leave your environment in a bad state. So you've got all your details sorted. Now you need some actual responders to live through these incidents. So we found that 3 to 4 people per 2 to 3 incidents is a sweet spot, just for enough people for people to naturally fall into roles that you'd see in incidents. So a lead, someone mitigating issues, someone maybe doing communications, and having no one that's idle. You also might want to decide whether you're going to run these simultaneously or in parallel if you want to have more of a major outage situation. Finally, you might want to consider mixing junior and senior responders so that the junior responders can be upskilled from the senior responders, helping them through things. And as a small organization, we've run these by mixing product teams, but if you're a bigger organization, you might want to do it for just one product team. And you might also want to involve customer success when you're running these. So this might be the first time that your customer success are able to experience an incident firsthand before they actually experience the real thing. So it's a good thing to consider. Cool, so we're nearly at the fun bit. Some final logistics that you might want to note on. So we found out one session with the intros, breakages, and regroup is about half day. Remember to book rooms if you are in office, unless you want to run things remotely, which we found is extra hard mode. You might want to organize food in stacks to keep things lightweight. And on the villain side, you'll want a private villain channel so that you can coordinate things on the day. You'll also want a public channel for your engineers to be able to chat to each other on and also declare incidents from. And finally, you should decide if you're going to use an incident tool or how you're going to declare those incidents and communicate among each other. Cool. Finally, it's game time. This is the fun bit for the villains. So you'll want to welcome your responders, bring everyone together, and give them idea of timings. So we're not there to catch them out. They should know when a page is actually here. You should also establish rules of engagement. So does it look broken in production? If it does, we should all stop and treat it as a real incident. Let them know what tool they should be using. So are we using just a channel? Are we using a dedicated incident tool? And finally, you might want to run an icebreaker or a warm-up exercise just to get everyone in the mood for the day. So we've run tabletop exercises here where we pull up a real alert, for example, that we've been through and ask people to discuss it. It's a great way to get more junior responders to be warmed up as well and have a first-hand experience of their first major incident. So once you're done with that, you can set off your responders so the villains can start breaking. And hopefully they're all thrilled with anticipation and ready to be productive. Cool, so as a villain, the fun starts for you. So you've got your private channel, and you should walk through your to-do list that you've very well prepared. So here you can see me and Ben, our platform engineers, one of our platform engineers, stepping through our to-do list. So I've put someone on a call schedule, I've kicked off some background noise, and Ben has confirmed that our dependency is dead. And as you're watching your participants about to stress, you might feel like you're in this Hunger Games war room. And there's a few things to keep in mind. So we talked about how incidents are stressful, and we want these to feel like the real deal, but not too stressful. So you can use your engineering manager to keep things light with coffee orders, for example. You should make it clear that these incidents are fake, so you should use fake customer names where you can. So this is me role-playing as Lucy, one of our customer success managers. And finally, you can use role-play to break the tension. So here's Harry asking for help from one of our platform engineers, and Ben role-playing as him having a rove in the woods, so being unable to help. Sorry, Harry. Cool. And the other thing to note is that you want to be finding weaknesses as you go. So in a normal incident, when you're all heads down responding, you might be hitting some rough edges in your observability, not finding a dashboard, or finding a runbook annoying to go through. As a villain, you're in a prime position to be taking note of these things, and you should mark them down because each one will be a free follow-up at the end of the game day. Cool, so let's step through game days. What does it actually look like? And it's going to look very similar to a real incident. So here you can see I've posted in a makeshift engineering channel saying that our scribe can't join our call. So scribe is the product that transcribes incident calls. And someone's declared an incident from the message. And Gabriel and Tom, our responders, have jumped in and can also already see that latency seems up. And I nudge in as Lucy, our customer success manager, and say that it doesn't seem to be just us. It seems to be applicable to many customers. Off of this, Gabriel decides we should probably draft a status page update if it's affecting more than one customer. And Tom has found the issue to be due to US East 1 being down, so he's going to follow the runbook to switch over our region. That means Scribe is now joining, and we can resolve the status page incident, which is great. And we've just gone through and into an incident. It might feel a bit boring, but you've just done this without an actual outage and confirmed that your processes work well. Cool. So once you're happy with how your responders have responded to all your villain scenarios, you want to let them know there's not going to be any more pages. If anything happens now, it's real. And you want to have your responders give your responders some time to breathe. And while they have some time to relax, remember to clean up your breakages. Otherwise, you might end up like Joe, who was very confused why his feature wasn't working in staging, and Ben had to profusely apologize. Yeah, that to-do list does come in handy on the day. Cool, so you've ran your game day, and you've just run through the hard part. Now you get to reap the rewards. So we like to talk about the day using a retrospective, so going over what went well and what didn't go well, and people can talk about what they felt we did well, so like updates and what they thought they didn't feel as much confident on. And that can bring you, again, a whole bunch of follow-ups. And you want to write down those gaps so you can then go and fix them. Because at this point, you've got a huge list of follow-ups that has just been free. So based on the retrospective and the notes you took as a villain and what you spotted both during the incidents and when you were prepping for them, those real product or alerting weak spots, you can fix them before they bite you for real. And finally, you want to celebrate. So you should have met your goal, and your engineers should be very proud of themselves for what they've just gone through, and so you should celebrate that. So you can end it on a fun activity, like a lunch or a dinner or a social, and for more recent game days, we like to make game days collectibles. So we made some stickers for engineers to wear on their laptop. And this was from me going around the office yesterday trying to take photos of all the engineer laptops. And it makes it more fun, it ties it all together, and engineers will ask to do it again, which will build that culture of reliability. So we've gone through the process for an entire day. If you feel like being a villain now, you should take a photo. The first game day you'll run will be the hardest one to adapt to your own processes, but then it will be something that you want to repeat over and over again, and hopefully that engineers will be asking for. And it will help you and others like me not to just freeze in stressful incident scenarios. So incidents improve your reliability, and now you can go and cause them intentionally. Thank you.